beautiful people, and welcome. In today's video, we're going to be graphing the tangent function with some transformations happening to that function. Just a disclaimer, as always, I am human, so if you catch a mistake, if you notice a mistake, please let me know where that occurs so that way we both can learn from my mistake. As always, if you hear anything in the background, I do apologize. Today we are recording from home and Miss Solanas is being a happy kitty in the background. So I do apologize if you hear any background noise. All right, let's get started. So there are four things that I want to point out. First thing I want to point out, or the zeroth thing that I want to point out, is that we are not dealing with vertical shifts. So we're not dealing with up and down. I want to go over these types of examples first without a vertical shift. Then I want to introduce the vertical shift to you and explain what we are doing with that. So when we are dealing with a tangent function like this, in this format, there are four things that I'm going to be pointing out to you. So the first thing that you need to know is, number one, let me go ahead and turn off the light here so you can see it better. Okay, number one is that you need to find two consecutive asymptotes by finding an interval containing, that's incorrect, containing one period. Okay, what that means is we know that a tangent function has a period between pi halves and pi. If you haven't seen that yet, go ahead and watch my introduction to graphing tangent. I believe that is listed down below, and if it's not, I'm going to go ahead and attach it or link it down below so you can watch that. So a tangent wave, its period length is 1 pi. So it goes from negative pi halves all the way to pi halves. That the distance is of pi, and so tangent distance is pi. So let me back up a little bit. We know already that this is our asymptote, or excuse me, our amplitude. Amplitude. Previously, we talked about B being used to find our period. I'm actually going to omit that while graphing tangent, and I'm going to show you a different way to use this information here. So the first thing is we're going to find consecutive asymptotes by finding an interval containing one period. So how do we do that? So since we know the interval of our tangent function goes between negative pi halves and positive pi halves, we're going to set this inside bubble b times x minus c in that parameter. So somewhere between negative pi halves and pi halves, we're going to have this right here. Now, depending on what your b value is, depending on what your c value is, or in some cases you'll see h for your horizontal, will depend on what those parameters or where those asymptotes occur. So that brings us to step number 1.5. So we're going to continue step number 1. And so what you need to do in step number 1 is you're going to set Bx minus c equal to negative pi halves and Bx minus c equal to pi halves, positive pi halves. And from there, you're going to solve for x. Once you solve for x, that is where you have your asymptotes. So you have locations. It's not just a location, it's locations plural. Okay, so that's step number 1. You locate or identify your asymptotes by setting Bx minus c equal to negative pi halves and positive pi halves. Step number 2 is identify an X-intercept, and that is midway between the consecutive and consecutive, that's with an S, consecutive asymptotes. Okay, so what that means is you know where the left asymptote will be, you know where the right asymptote will be as well. So in the characteristics of a tangent function, somewhere between the left-hand asymptote and right-hand asymptote, it's going to cross the X-intercept, or, I'm going to say or, depending on if you have a vertical shift, it's going to cross what we call in our class our midline. Okay, it's going to cross our midline. So we need to find out where, and I'm going to put X-intercept here, underlined. The X-intercept is the X-intercept because we don't have a vertical shift. We don't have up or down. If we do have a vertical shift, that means this X-intercept would be just your midline. So it's midway between the consecutive asymptotes. So easiest way to do that is you take your two asymptotes. So you take your one value for X, take your other value for X, add it, divide by 2, and you're going to find what that is. So let me change markers here. So you're going to say your first X value plus your second X value divided by 2, and that's going to be your X-intercept, or your X value that's going to be on your midline. Once we have that, so we have your asymptotes, we found your X-intercept or your point on the midline. Step number 3 is we're going to find the points on the graph 1/4 and 3/4 of the way between consecutive asymptotes. Let me shift this up. Okay, what this means, we have one value. Let me see if I can sketch this out for you. And again, your first asymptote and your second asymptote can be anywhere. The only thing we know about those two asymptotes is that their distance between them is pi, because that is our 1 period. So let's just use here. So I'm going to call this x1, call this x2. And so what we're trying to find is the value 1/4 of the way and 3/4 of the way. So we're trying to find this value and this value. What is that? Okay. Once you have these values here, you're going to you're going to use your A or your amplitude to find out what the Y value. So find the points on the graph 1/4 and 3/4 of the way between your consecutive asymptotes. So these or those are the X coordinates. And then using amplitude and your K value, find y. And again, this will make a little bit more sense once we start with an example. And because I want to apply these rules not only to something that doesn't have a vertical translation or a vertical shift, but I want you guys to be able to use these words with, or these steps with something with a shift up and down. Okay, so step number 4, we're almost done. Number 4, super easy. Graph. In my class, I'm only going to ask you to graph one period. Sometimes what you're going to notice in your examples or in your homework, on an assessment, you're only going to have to do one period, but sometimes on a quiz, not a quiz, on homework, you're going to have to graph multiple, so just keep the pattern going. You should be fine, but I'm only asking you to graph one period. Let's go ahead and move on with an example. Let's start one without AK, and then I'll show you how to apply the rules with AK. Okay, so example number 1. And for example number 1, we're going to graph y equals 2 tangent of x divided by 2. And again, it's telling you what to graph. And for this one, it's asking you to graph for negative pi all the way to 3 pi. So it wants to see, like if you were to use Desmos or if you were to use your calculator, and you're going to set the window from negative pi to 3 pi, and it wants to see what do you have between those two values. So we're going to worry about that at the end, step number 4, when we're graphing. Right now, all we're going to do is kind of use that to identify our information. So step number 1 is I'm going to set my amplitude. My amplitude is 2. Tangent. Let me actually do one more thing. I'm noticing that I don't have a minus, I have a positive function. That means that my tangent is going to go increasing from left to right. This section right here is the same thing as saying 1/2 times x. So this is my Bx plus c. So if we go back to our steps, step number 1 is to find your amplitude. So what you're going to do is you're going to set Bx plus c equal to pi halves and Bx plus c equal to negative pi halves. So your Bx plus c in this case is 1/2 x equal to pi halves, and then this is 1/2 x equal to negative pi halves. I'm going to multiply both sides by 2. So I have x is equal to pi, and then this one here, again, I'm going to multiply by 2. I have x is equal to negative pi. So that means when I am sketching my graph, I have an asymptote at pi and I have an asymptote at negative pi. Now I'm going to move on to step number 2, which is identifying your x-intercept. And again, x-intercept because I don't have a k. If I had a k or a vertical shift, then that will change. That will be on my midline. So my x-intercept. So my x-intercept is, I take these two values, divide by 2. So I'm going to say my x1 plus x2 divided by 2. This is 0 divided by 2, which is 0. So I have an x-intercept at 0, 0. Step number 3 is find the points that are 1/4 and 3/4 of the way. Now this is where I'm going to start graphing because I'm a visual person. It's easier for me to see things this way instead of just writing it out numerically. So I'm going to graph. So I know that I need my window from, right here, negative pi to 3 pi. I know that my amplitude, my asymptote is at negative pi. So I'm going to set my negative pi here. So this means negative pi. Let me make it smaller. Let me make it smaller a little bit. If this is negative pi, so I need 3 pi's here, so that's going to be much longer. So let me get an eraser. Actually, let's do this. This is going to be 2 pi. This is going to be negative pi, pi, 2 pi, 3 pi. Okay, so I have a amplitude. I keep saying amplitude. I don't know why I keep doing that. Asymptote. I have an asymptote at negative pi. That's from step number 1. Make sure you're indicating your amplitude. I can't see it. I did it again. Asymptote. Asymptote. Make sure you're indicating your asymptote with a dotted line. And then make sure that you are, because our window is a little bit more open, that we continue with our asymptote pattern. So I have 1, right, here's a pi, here's another pi, here's a pi, here's another pi, continue the pattern. Okay, and so for step number 3, it's asking us for what is the distance that is 1/4 of the way and 3/4 of the way. So we want to know what this distance is, and we want to know what this distance is. Visually, it's easier for me to see. I can see that this is going to be 0, 0, because I know my X-intercept is going to be at 0, 0. We know that from step number 2. So then this right here is going to be pi halves, and this right here is going to be negative pi halves. Okay, then so here is pi halves, negative pi halves, and positive pi halves. So now we use our amplitude, let me say it correctly, our amplitude to find out how far up and how far down from our midline we go. So in this case, our amplitude is 2, so we go up 2 and down 2. Make sure you have that in the correct spot because we are increasing. Here's 1, here's 2, here's 1, here's 2. So here is negative 2, here is positive 2, and we're going to increase from left to right. And again, here are the 2 points. Now for this one, once you have this section already finished, I'm not too concerned about you filling in these 2 values. I do need at least 1 period filled in. The rest you can just show me like this. All right, you guys, and there you have it. Step number 4 is graph, and we already did that. I hope you don't have questions, but of course you do have questions, and that's okay. Please let me know what those questions are so that way I can answer them. Message me, email me, whatever you need to do. Let's do one more quick example of how to graph with a K value. So again, let's do an example. This is example 2. Y equals, let's do this one. Tangent of x plus pi fourths plus, oh, I don't know, let's do plus 1. Let's do plus 2 since our amplitude is 1, so let's do plus 2. All right, so first thing I'm going to identify are some things with the function that's given. I notice that it is positive, so it is going to be an increasing function. I notice that I don't have a number in front. That means my amplitude is 1. Here is my Bx plus c. Here is my K value. And that means I'm going to shift up by 2. And we're going to start out exactly the way that we did. So step number 1, I'm going to try to make it smaller this time. We're going to set our Bx plus c equal to negative pi halves. And we're going to set our Bx plus c equal to pi halves. So we have, what do we have? X plus pi fourth is equal to negative pi halves. X plus pi fourths is equal to pi halves. Okay, so what am I going to do? I'm going to subtract pi fourths, both sides. I'm going to convert this to a common denominator, so I have negative 2 pi fourths minus pi fourths, and this is 2 pi fourths minus pi fourths. So x is equal to negative 3 pi fourths, and what do I have here? I have x is equal to pi fourths. So here is 1, here's the second asymptote. So from here we're going to go to step number 2. Step number 2, I'll leave this area to graph. Step number 2 is our X-intercept, or in this case, since we do have a K value, a vertical shift, that K value will become our kind of our midline, and then we're going to shift that up. So you're going to do exactly the same thing. So you're going to take negative 3 pi fourths plus pi fourths, exactly what we did, divide by 2. So what do I have here? Negative 3 pi fourths plus pi fourths. That is negative 2 pi fourths divided by 2, which is the same thing as saying, I can simplify this, but I'm going to choose not to, because I'm noticing I have a 2 here, so I'm going to multiply by the reciprocal, which is 1/2. Then I'm going to cancel out my 2's, which means I have a negative pi fourth. Now this right here is your x coordinate. And because we have a k value, our y coordinate is going to be our k value. So I have negative pi fourths, comma, 2. Okay, like we did last time, right about step number 3, that's where I want to start graphing. Okay, so what do I have here? I have an asymptote. I hesitated there for a second. I have an asymptote at negative 3 pi fourths. So 1 pi fourth, 2 pi fourths, 3 pi fourths. Make sure you're using a dotted line. And we have pi fourths. Okay, so we have a midline, I'm calling it a midline, at 2. So here's 1, here's 2. Okay, and then where's this point? At negative pi fourths, we are going up to our midline, which is at 2. Step number 3 says you need to find the middle of the middle. So this one, in my opinion, is a little bit easier because you can actually see it. It's going up and down by pi fourths. So this one here is 2 pi fourths, negative. And then this one's going to be at 0. So at 0, again, we're looking here. We're going to have an increasing function, increasing from left to right because we have a positive function here. So then we have to use our amplitude. Our amplitude is 1. So from the midline, we're going up 1 and down 1. So that means 3 and 1. So at 0, we're going up to 3. And at negative 2 pi fourths, we're going up to 4. So again, going down this way, going up this way. We want a smooth curve. And there you have it. Again, in my class, I'm only asking you to graph one period. Hopefully, the steps are going to be very helpful. Again, if you have any questions, please reach out. Ask me lots of questions. I gladly welcome them. And again, if you catch any mistakes, please let me know so that way we both can learn from my mistakes. Thank you again for watching, and I'll see you next time. Bye.